Good morning, students. Jai Swaminarayan. Welcome to video lecture. In the last lecture, students, we had discussed up to sum number 10. Today, students, we are starting from sum number 11 of exercise 13.1. A fair dice is rolled. Okay. Sample space of rolling a fair dice is set of integers 1, 2, 3, 4, 5, 6. Now events E, F and G are as given 1, 3, 5. So odd integer appears. Event F 2, 3. Event G is 2, 3, 4, 5. Find the following probabilities. Answer 1 part A. Conditional probability of E given F, and part B. Conditional probability of F given E. Okay, students. This is what we have to do and understand. Now, students, here I hope that all of you have understood the basic formulas. So, directly, students, we are going to apply the formulas. This is probability of E intersection F upon probability of F. Now, what is E intersection F? Then I can say it is singleton set 3. So that probability I am writing directly, which is 1 by 6. And P of F, here we can say P of E will be 3 by 6. This implies P of F will be 2 by 5. And this implies P of G will be 4 by 6. So this is 3 by 6. So this answer is 1 by 3. Now, all of you please concentrate. Don't say E oblique F. Always say conditional probability of E given F. Conditional probability of F given E will be probability of F intersection E upon probability of E. Still, this is 1 by 6. Probability. Oh, sorry. Here it was F. Sorry, students. I should have written here. Oh, sorry, this is 2 by 6, sorry. So this will be 1 by 2. Sorry, by mistake, students, I got 5. This is 3 by 6, so this will be 1 by 2. Sorry, students, that I written 2 by 5. It was just a slip of pen. Now, the second part of the sum is conditional probability of E given G. Okay, answer 2. Part A. Conditional probability of E given G and conditional probability of G given E. Okay. Now, students, pay attention. We have to first of all write the formulas. This will be probability of E intersection G upon probability of G. Now, what is E intersection G? Then I can say, students, E intersection G will be 3 and 5. So its probability will be 2 by 6. P of G is 4 by 6. So this turns out to be 1 by 2. This is probability of G intersection E upon probability of E. So this is still 2 by 6. Probability of E is 3 by 6. So this answer is 2/3. Students, here intersections I have written directly, and I hope that much, students, you can very easily understand. Intersection, students, I have written directly. E and G has 2 elements common, which are 3 and 5. Now, the third part of the answer is probability of E union F given G. E union F given G, probability of E union F intersection G upon probability of G. Now E union F is 1, 2, 3, 5 and its intersection with G will be 2, 3 and 5. So this probability will be 3 by 6 upon 4 by 6. So this is 3/4. Second part is probability of E intersection F given G. So this is probability of E intersection F intersection G upon probability of G. Common element 2. All 3 is only 3. And so this probability is 1 by 6 upon 4 by 6. So this answer is 1 by 4. This type of question, or students, this question is very important from MCQ point of view. So students, I wish that you should understand this very perfectly from MCQ point of view. This is very important, students, from MCQ point of view. So all of you must understand this perfectly, students. This is important sum. Okay, now students, we are doing sum number 12. Now students, we are doing sum number 12. Today students, we will, I think, complete this exercise easily. Now the most interesting sum starts from 12. Assume that each born child is equally likely to be a boy or a girl. Equally likely. Say, getting a head or tail are equally likely outcomes because probability of getting a head is 1 by 2 and probability of getting a tail is also 1 by 2. Same way, assuming that probability of girl and boy are equally likely, it means probability of boy is equal to probability of girl is equal to 1 by 2. Probability of a boy is equal to probability of a girl, and that is equal to 1 by 2. If a family has 2 children, what is the conditional probability? First of all, sample space of children is very similar to sample space of points. Say, and outcome is either a boy or a girl. So for the first child also we have 2 options, and students, for the second child also we have 2 options, either a boy or a girl. So sample space of children is in, you can say, parallel with sample space of tossing a coin. In coin also we multiply HT as the number of tosses goes. Same way for children also we multiply BG according to the number of children. So this comes out to be boy and boy, boy and girl, girl and boy, and girl and girl. So students, the total outcomes are 4. So the sample space of 2 children of a family goes in parallel with sample space of tossing a coin. What is the conditional probability that both are girls given that youngest is a girl? Given that. So I highlighted event A. Youngest is a girl. So, youngest is a girl means BG and GG. Youngest is a girl, students, it means that the second child is a girl. Those outcomes are right, and this probability works out to be 2 by 4. Now, conditional probability that both are girls. So, event B, both are girls. So this has only one outcome, which is G and G. And definitely A intersection B is equal to B. So probability of A intersection B is 1/4. Therefore, the conditional probability of B given A is P of B given A is equal to P of B intersection A upon P of A. So 1/4 upon 2/4. So this works out to be, students, 1/2. In this type of sums, the basic point is to understand the method. Assuming that a boy or a girl child are equally likely, it is very similar to head and tail students. So keep this in mind. And correspondingly, students, we can do this up. And second, that at least one is a girl. Okay, this is base, part 2. Event C, at least one child is a girl. B means same. So here we have to write BG, GB and GG, and P of C comes out to be 3/4. Then definitely, students, B intersection C is B. Therefore, P of B intersection C still remains 1/4. Therefore, the conditional probability of B given C is P of B given C, which is equal to P of B intersection C upon P of C 1/4 upon 3/4. So this answer is 1/3, students. So this type of sums are very, very important, students, and you have to understand the method, perfect subjective method to do and write the sum. Students, in probability, it is very important to know how to write a particular sum. The moment, students, you deviate from standard steps, you will not get full marks in subjective part. So, students, you have to be very careful and very cautious in understanding and writing, students, the corresponding steps. Okay, now, students, pay attention. Question 30. The question is a bit long, and in this type of questions, data collection, students, always matters a lot. An instructor has a question bank consisting of 300 easy true or false questions, 200 difficult true or false questions, and 500 easy multiple choice question and 400 difficult. So two types of questions are there. True or false, T/F and MCQ. They have their level easy and difficult, and let us total. So how many easy true or false type of questions were there? 300. And difficult 200. Total questions of true or false were 500. Then how many easy MCQs were there? 500. And difficult MCQs were 400. This comes out to be 900. This total is 800. This total is 600. This total is 1400. This is in general N. Total number of questions. So this works out to be, students. So in probability, students, we have to focus on the basics. And we have to collect the data very perfectly, students. If our data collection is not perfect, students, in probability, then it is going to harass us. So, let us go further. If a question is selected at random from the question bank, so sample space n of s will be 1400, then what is the probability that it will be an easy question given that it is a multiple choice question, given that I highlight it is base event A, a question is MCQ. How many MCQs? We have 900. So probability of event A is 900 upon 1400, and that works out to be 914 students. It is an easy question. That is event B. Event B. The question is easy. Now, how many easy questions we have written and writing? Easy MCQ type of questions are 500. So, probability of A intersection B will be 500 upon 1400, and that is nothing but 5 by 14. That, students, works out to be 5 by 14. So this we have to perfectly understand and memorize. How many easy questions were there? Then 300 true or false and MCQ 500. So total easy questions were 800, but easy MCQs were only 500. Therefore, the conditional probability of B given A works out to be P of B given A is equal to P of B intersection A upon P of A. So the answer is 5 by 9. 14 and 14 gets cancelled. So this type of sum, students, data collection plays an important role. The moment you deviate from data collection, students, you will not get the perfect answer. Okay, let us do sum number 14. Now, students, the 14th sum. Always read the question very perfectly before writing the sample space. Now, given that two numbers appearing on throwing two dice are different, sample space of tossing two dice once is S is equal to set of integers 1, 2, 3, 4, 5, 6 into set of integers 1, 2, 3, 4, 5, 6. So, total outcomes of our sample space are 6 square, and that is nothing but students 36. Total outcomes of our sample space are 36. Given that two numbers appearing on a pair of dice are different, given that this time let us write this event as x. Event x, two numbers on a pair of dice are different. Given that two numbers on means numbers obtained on throwing a pair dice are different, means we do not have a doublet. Students, not having doublet means 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. So this will have S minus 1, 1, 2, 2, sorry, 3, 3, 4, 4, 5, 5 and 6, 6. So probability of x will be 30 by 36 and that is 5 by 6. This, students, you have to understand. 1, 1 will not come, but 1, 2, 1, 3, 1, 4, 1, 5, 1, 6 will come. 2, 1, 2, 2 will not come, but 2, 1, 2, 3, 2, 4, 2, 5, 2, 6. Like that. 3, 1, 3, 2, 3, 4, 3, 5, 3, 6. Given that numbers of variables throwing a pair of dice are different, find the probability of the given. The sum of numbers on the dice is 4. Given y. Sum of numbers on pair of dice is 4. Now locate the pairs where, students, the sum of numbers is exactly 4. So definitely 1, 3. Correspondingly, I write reverse 3, 1 and then 2, 2. So x intersection y will be 1, 3 and 3, 1, and therefore probability of x intersection y is 2 by 36, and that works out to be, students, 1 by 18. This is very, very important, students. So the probability of x intersection y, students, works out to be 1 by 18. Now the conditional probability of y d1 x, I have changed the name of events. Probability of y d1x is probability of y intersection x upon probability of x. So this is 2 by 36 upon 30 by 36. So the final answer is 1 by 15. This is very important. Students, this is the most important and easiest topic of the entire chapter. On the condition that, students, you know how to write the subjective. On the condition that, students, you know how to write subjective. So be very careful and mark question number 15 as the most important sum. Mark, students, question number 15 as the most important sum of the entire exercise 13.1. Consider the experiment of throwing a dice. If a multiple of 3 comes up, consider the experiment of throwing a dice. So, all of you know that we have the outcomes as set of integers 1 to 6. Now, all of you know, in a set, the order in which elements are written, students, is not at all important. If a multiple of 3 comes, the dice again tossed. With this, we toss the dice again. Means, with 3, I can have any one of the 6 integers. And with 6 also, students, I can have any one of the 6 integers. And if any other number comes, a coin is tossed. Okay, with this, a coin is tossed. So we can have 1H1, T, 2H, 2T, 4H, 4T, 5H, and 5 and T. So 6 into 2, 12. So this pairs will be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6, 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 1 H, 2 H, 4 H, 5 H, 1 T, 2 and T, 4 and T, 5 and T. This is a cumulative sample space where the experiment has 2 stages. This type of sums you recall, students, we have done in 11 standard. You recall this type of sums, students. This type of sums we have done, students, in 11 standard. The experiment has 2 stages. Mind you, 12 and another 8. I cannot write n is equal to 12 plus 8, 20, because different elements may have different probabilities. Here the sample space is such that all the elements are not equally likely. Pair 3, 1 has probability 1 by 36 because it is obtained when a dice is rolled twice. Whereas pair 1H has probability 1 by pair 1H has probability 1 by 12 because that is obtained when a dice and a coin is rolled. So different elements has different probabilities, so n is equal to 20 is not possible. Be careful. Find the conditional probability of the event. The coin shows a tail, given that at least one die shows a 3. I highlight given event A. At least one die shows 3. So mark all the elements with 3. 1, 2, 3, 4, 5, 6, 7. So probability of event A is 7 times 1 by 36, and so 7 by 36. Each individual pair of numbers, students, individual pair of numbers has probability 1 by 36, and the pair with H number has probability 1 by 12. Then what is the conditional probability that coin shows a tail? Event B, coin shows a tail. Now if coin shows tail, means I have to write 1T, 2T, 4T, 5T. And definitely A intersection B is null set. A and B are mutually exclusive event. So probability of A intersection B turns out to be 0 for mutually exclusive events A and B. P of A intersection B will be 0. Therefore, the conditional probability of B given A, P of B given A is equal to P of B intersection A upon P of A, and that works out to be 0 by 7 by 36. So 0. Once again, understand here, students, that the pair of numbers has probability 1 by 36, and the pair number and either head or tail has probability 1 by element 1h has probability 1 by 2. Okay, students. So now I think MCQ 16 and MCQ 17 we have already discussed. So students, this completes our topic of conditional probability, and conditional probability is the base for entire chapter. If you know conditional probability, then and then you will know law of multiplication. If you know law of multiplication, then and then you will know independent events. And further topics are TPT, total probability theorem, and base theorem. Though these topics have been removed, but the base up to exercise 13.3 is students conditional probability. So students, here we conclude our lecture and exercise 13.1. From the next lecture onwards, we will take multiplication rule or multiplication theorem on probability. Do these sums perfectly. I'll see you students in the next lecture. Thank you, students.